Uh, Binit sir, with your kind permission, we can start the program.
Why not? Professor Panda तैयार हैं तो बस चलो कर दीजिए. Sure, go ahead please.
Ganapati sir, with your permission, we are starting the program, sir.
Yes.
Yeah. On behalf of Electronics and ICT Academy at MNIT Jaipur, I welcome all the participants, speaker, dignitaries to this particular faculty development program on advanced optimization technique with MATLAB. It is supported by Ministry of Electronics and Information Technology, Government of India, and jointly organized by MNIT Jaipur, NIT Patna, NIT Warangal, IIT DM Jabalpur, IIT Roorkee, and IIT Guwahati. This is a 40-hour intensive online faculty development program in which there are 26 keynote speakers from various IITs, NITs, IIITs, and other Indian and foreign universities, as well as from industry. In this, there are 32 theory sessions and 6 MATLAB-based laboratory sessions are there. There will be 2 online quizzes in this particular faculty development program, which will be held on Fridays. So every day there will be 3 lecture hours from 4 o'clock to 7:30, and on Saturday, Sunday there will be one hour extra for it. So with this, the entire program completes 40 hours of session. This program is bifurcated into 4 modules. The first module comprises of fundamental of optimization techniques, in which it will cover the classical optimization, constraint optimization techniques, linear programming, linear nonlinear optimization techniques. The module 2 covers the various nature-inspired optimization algorithms like genetic algorithm, particle swarm optimization, ant colony optimization, artificial bee colony, and other nature-inspired algorithms. Module 3 comprises of multi and many objective optimization algorithms, in which recently developed NSGA 3, NSGA 2, and various other multi-objective algorithms will be covered. The module 4 comprises of real-life application of these optimization techniques to wireless sensor network, nonlinear system identification, data clustering, adaptive noise control, and many other applications. The speakers in this advanced optimization technique faculty development program are Dr. Anupam Trivedi, who is a senior scientist at Department of Electrical and Computer Engineering from National University of Singapore, who is the winner of Real Parameter Constraint Optimization Competition in IEEE Congress on Evolutionary Competition, held this last year at Yokohama, Japan. Professor Narayan Prasad Padhi, Director of our Institute MNIT Jaipur and Director of IIIT Kota. He is also the recipient of Samanta Chandrasekhar Award from DST Government of Odisha and author of famous book on soft computing with MATLAB programming of Oxford University Press. Another eminent speaker is Professor Vijay Ketan Panigrahi, Fellow IEEE, Head of Center for Automotive Research and Tribology, Professor, Department of Electrical Engineering, IIT Delhi. And he will be talking about particle swarm optimization and multi-objective optimization. The other eminent speakers are Professor Ratnajit Bhattacharya, Head, Mehta School of Data Science and Artificial Intelligence, Professor of IIT Guwahati. my supervisor, Professor Ganapati Panda, who is the former Deputy Director of IIT Bhubaneswar. He is the INA Outstanding Teacher Awardee, and Biju Patnaik Award he received from DST Government of Odisha. Today he will be delivering the talk, as well as Professor Kusumdeep from Professor Emeritus from Department of Mathematics, IIT Roorkee, and she is very popular for her book Nature Inspired Optimization and Introduction from McGraw-Hill. Other eminent speakers are Professor Swagatam Das, who is the founder editor-in-chief of journal Swarm and Evolutionary Competition, Elsevier. Professor Rajesh Kumar, the IEEE IAS Distinguished Lecturer Awardee for the year 2024 and 25. Now he is there at the University of Johannesburg, South Africa. The other eminent speaker is Professor Nitin George, Eco Chair Professor at Department of Electrical Engineering, IIT Gandhinagar. Dr. Shifanna Shah from Department of Computer Engineering, IIT Patna, recipient of NASCOM AI Game Changer Awardee 2024 and INSA Young Associate 2024, will also deliver the talk in this particular FDP. Dr. Jagdish Bansal from Department of Mathematics, South Asian University, and member of Board of Editors of journal Engineering Application of Artificial Intelligence, Elsevier, will also share his keynote talk. Dr. Pyari Mohan Pradhan, Associate Professor, Department of Electronics and Communication Engineering, IIT Roorkee, will deliver his expert talk. The other eminent speaker is Dr. Abhishek Gupta, Ramanujan Fellow from IIT Goa, who is the founder researcher of multitask optimization algorithm, will share his experience. Dr. Ajit Sahu, Associate Professor, Department of Electronics Communication Engineering, NIT Rourkela, will deliver the talk. Dr. Vasundhara from Department of Electronics and Communication Engineering, NIT Warangal, will deliver the talk. Along with that, we have 11 more speakers from various universities who will be sharing their experience on this particular platform. They are Dr. Anil Kumar from IIIT Jabalpur, Dr. Dinesh Kumar Kothari from IIIT Ranchi, Dr. Shitanshu Sahu from BIT Mesra, Dr. Annapurna Panda from Shiksha Anusandhan, Dr. Rahul Kumar Vijay from Department of Computer Science, Banasthali University, Dr. Ashish Sharma from Mahe, Bengaluru, Dr. Rachna Gupta from R Software, Vadodara, Dr. Gunjan Soni from Department of Mechanical Engineering, MNIT Jaipur, and Dr. Deepak Ranjan from MNIT Jaipur. Along with that, myself and Dr. Ila Sharma, the coordinator of this course, also will be sharing the experience and delivering the talk. This is the detailed outline of this particular faculty development program for the next 7 days. You can look at the details of the program starting from today. This is the detailed schedule of the program, which has already been emailed to you. Actually, I want to announce that this is the 10th version of this faculty development program on advanced optimization technique. It started long back on 2015, and this is on the year 2025. We have the 10th version of this particular program. And this is the details of the program held in last years. For this year's program, AOT 2025, we have combined from MNIT Jaipur, NIT Patna, IIIT Jabalpur, IIT Guwahati, NIT Warangal, and IIT Roorkee, the various coordinators. They are Dr. Ila Sharma, Dr. Mukesh Kumar from NIT Patna, Dr. Piyush Kumar from NIT Patna, Professor Praveen K. Padhi from IIT DM Jabalpur, Professor Ratnajit Bhattacharya from IIT Guwahati, Dr. Manjubala from NIT Warangal, Dr. Saurabh Khanna from IIT Roorkee, and Professor Sanjeev Mahant from IIT Roorkee. In this particular advanced optimization technique program, total 466 participants have been registered. From MNIT Jaipur, the total registration is 191, NIT Patna 121, NIT Warangal 26, IIT Guwahati 6, IIT DM Jabalpur 99, and IIT Roorkee 23. So, Professor Narayan Prasad Padhi sir, Director MNIT Jaipur and Director IIT Kota will join our program very soon. And along with me here, Professor Binit Saula sir is there, investigator of our academy. Professor Love Bhargav sir is here. Dr. Ravi Kumar Madila is also sitting over here from our academy. So along with this, I invite Professor Ganapati Panda sir to share few words about this FDP, and Professor B.K. Panigrahi sir is also here. So I will tell first Professor Ganapati sir to speak a few words, then Professor B.K. Panigrahi sir to share few words.
Thank you. Thank you, Dr. Nanda, for giving me an opportunity, to speak few words on the first day of this FDP. I'm thankful to Director of MNIT, Professor Padhi, and Professor Dr. Nanda for this opportunity given to me. It is one of the very interesting FDP program. It doesn't limit to electrical sciences. It is a program which will be helpful to all branches of engineering, science, and management. Basically, in the initial part, optimization techniques and its application were being used by operation research people or management people, mathematics people. But as the technology advances in any branch of engineering, science, and management, today optimization technique has become highly essential and beneficial, not only to the researcher and also in the industry. More details I'll be speaking in my first lecture for a duration of 1 hour. I request everybody participant to attend my first lecture. Optimization can be broadly divided into two parts. First part is the conventional optimization technique. These techniques have some limitation, some constraint, and to alleviate that, the new advanced method of optimization has come into being. These optimization techniques are mostly based on three things: evolutionary computing, nature-inspired technique, nature-inspired technique, and biologically inspired technique. Okay. And more details of this advanced technique will be told in my lecture. I'm sure since this FTP program has been collaboratively being done by 2 ITs, 3 NITs, and 1 triple IT. And I was going through the list of speakers, very eminent speakers, all are going to deliver their lecture. I'm sure that at the end of this program on 28th of February, those who are started, they will start their more research work in this field. It is a population-based distributed optimization technique. These types of techniques gives not only optimal solution, it also takes less time to solve the problem. This both single and multi-objective optimizations has lot of applications. This is the inaugural discussion. So I'll stop here, but I assure you, please attend my first lecture. I'm confident you'll get a introductory exposure and interest in this burning field of research in the field of science, engineering, and management. Thank you, MNIT, organizations, institutions, specifically to Professor Padi and Dr. Nanda for allowing me to speak few words in this inaugural session. Thank you. Thank you.
Thank you, sir, for enlightening us. Now I request Professor B.K. Panigrahi, sir, from IIT Delhi to speak few words.
Okay. Yeah. Very good afternoon to all of you. And there is nothing to speak more once you have listened to my guide, Professor Panda. And this is a great opportunity actually to share everything with Professor Panda, and my lecture is just after Professor Panda's lecture. But I must thank the organizer. You see, whenever there are 2 important IIT Roorkee, IIT Guwahati, and 3 NITs, NIT Jaipur, NIT Patna, NIT Warangal, and IIITM Jabalpur have come forward for this. Because see, we may give any name, like Professor Panda has told, whether it is a nature-inspired computing, whether it is a bio-inspired computing, whether it is swarm intelligence. So everything is almost the same type. How we can solve a particular problem. So these are the problem-solving methodologies we are looking into, which has tremendous application in science, engineering field. Even if in the morning when you get up and you have certain works to do and you have to go to bed by 10, so you also plan certain things. So optimization is basically the best planning I can talk of. So the question is how you can formulate it mathematically for a problem solving. And sometimes it is very difficult to formulate the problem mathematically. You have to solve it by some other means which is inspired by the nature. So I must thank the organizer. Perhaps this is the thing which is continuously they are evolving in every year. And looking into the spectrum of the speakers, I am very much confident that all these, you see, people sometimes tell all the algorithms are available in GitHub or somewhere else. That is not absolutely a problem. There are enough, plenty of books, plenty of material. But the question is, when you have an interaction with a person who has done all this research, then that creates something different. So that is most important. Otherwise, there are books, there are materials, there are codes, everything will be available. But every researcher has to understand how to approach a problem. So my point is, we can discuss the theory, we can discuss the application, you can discuss the problem solving, and altogether this is a very good program. I wish all these program a great success. Thanks to Professor Padi, Professor Nanda, and all these who are involved in shaping this particular program. Thank you all, and I'll again join with you around 5:10. Thank you.
Sure.
Thanks.
Thank you, sir. Thank you, sir. Now we have with us Professor Praveen Kumar Padi, sir, from IIT-DM, Jabalpur. Praveen Kumar Padi, sir.
Thank you, Dr. Nanda. Respected Professor Ganpati Panda sir, BK Professor Panigrahi sir, and other experts present here, and other faculty members, the coordinators, and the participants present here. So actually, this is the very popular course, the FDP, last some years, because I was associated with Dr. Nanda also, this advanced optimization techniques with MATLAB, because this is applicable, required for all the researcher from all the field, different fields. That's why the feedback also very good, and so the interaction is very good here in this program. So one thing I can say, all the participants can enjoy this program, they can understand the basics of this optimization techniques, and they can apply in different research areas, and they can interact with the experts for better understanding. I think I welcome all the participants, and I just tell you enjoy the program during this period from 17 to 28. Thank you very much. That is all.
Now I request Dr. Saurabh Khanna from IIT Roorkee to say a few words.
So thank you, Professor Nanda. So I must start by saying that this is the first time I am associated with coordinating this FDP on optimization theory. So I'm very pleasantly surprised to see a wide range of talks in all kind of related to theory, algorithms, as well as practical applications. And would surely like to be participated in coordination of this workshop going forward also in coming years. By the way, on behalf of IIT Roorkee and the EICT Academy here, we are all very excited to be participating in this coordination of this FDP workshop. And I can see that there are participants from everywhere, right? From all the states. So it's great to see that participation from different parts of India. And I also feel that optimization is something that we all as engineers should be good at, because it's one of the foundational pillars of the engineering and basic sciences. I would say like it is something which connects theory to practical world. Wherever, if you look at any engineering or basic science problem, ultimately when it all boils down to solving some kind of an optimization problem. And area of optimization is quite active as a research area. And as you can see that we have to deal with different problems in optimization theory itself, such as we have to design new type of cost functions, what cost functions would work, what cost functions would not work, dealing with different type of interesting constraints which come up in different practical applications, then how to deal with challenges related to solving high dimensional optimization, which is a big area now, because we are dealing with optimization variables which are running into billions and millions and billions, right? So that is quite challenging. And dealing with non-convex optimization, which is personally I find very interesting. So I see there is a great lineup of talks in this FDP, which is covering many of these challenges. So hopefully, I wish all the students and the faculty members who are participating here in this FDP to have a great time, including myself. I am pretty sure that we will all have a great time learning new optimization techniques and studying about them in depth. So yeah, I hope all of you will enjoy the workshop. So I would like to hand over to Professor Nanda.
Thank you, Dr. Saurabh. And now I request Dr. Manjubala VC from NIT Warangal to speak a few words.
Thank you, sir. Good afternoon to all the respected dignitaries and the participants present on this online platform. On behalf of E&ICT NIT Warangal, I welcome all of you to the inaugural session of this faculty development program, Advanced Optimization Techniques with MATLAB. So for this FDP, we are having eminent speakers throughout the India. So different speakers from various foreign universities, IITs, NITs, IIITs and industry. They will provide valuable insights regarding this course. So I hope all the participants will have a great time and you will get many information regarding the theoretical as well as the practical aspects of this optimization techniques. So once again, I welcome all of you to this faculty development program. Thank you, sir. Thank you.
Thank you, Dr. Manjubala. Now I request Dr. Piyush Kumar from NIT Patna to say a few words. Dr. Piyush Kumar, NIT Patna. Okay. So next, moving on, I request Professor Binit Sahula, sir, the Chief Investigator of our EICT Academy, sir, to say a few words.
Yeah, thank you, Dr. Nanda. I think at this outset, I would like to thank all the speakers for having kindly consented to interact with the participants. Thank you, Professor Panda. Thank you, Professor Panigrai and other speakers. I think this is an effort by all academies to bring up the best of the bench experts to the equally sincere attendees and audience here. And we are trying that way. So I congratulate Dr. Nanda for putting up such a nice effort to compile the schedule and requesting the experts. And I hope participants will gain from this program definitely, which will motivate us to bring up a few more programs in the next vacation session in summers and winters also, maybe repeating this program that way. So happy learning all the participants. And again, thank you all the experts for their benign presence in our program that way. And thanks to all joint principal coordinators also, along with Dr. Nanda, for putting up such efforts to bring it up. Thank you very much.
Thank you, sir, for enlightening us. So, as I mentioned, our director, sir, Professor N.P. Padi, sir, has conveyed his regards for this particular program, and he will be joining later on, and he will be also delivering talk in this particular program, faculty development program. He himself will deliver talk on 24th. Also, he will be joining at a later time. So I request Dr. Illa to say the vote of thanks.
Good evening, everyone. On behalf of Good evening, everyone. On behalf of EICT Academy MNIT Jaipur, I thank everyone who are present, our participants. Our special thanks to Professor Sahula sir who give us this opportunity to organize such a good FDP. I thank Panda sir to be here and to enlighten us every time whenever we are in need of. I also thank to Professor B.K. Panigrahi to give his addresses in our upcoming FDP. Apart from that, I thank every coordinators from the different EICT academies of NIT Patna, Warangal, Jabalpur, Roorkee and Guwahati. And also I thank to every participant that they have registered and they have seen such energy in this FDP, and I wish all of them best luck and have a happy learning. On this note, I am not taking some extra time. I think I invite Professor Panda sir to start his address. Thank you, everyone.
So I request Professor Ganapati Panda sir to start the inaugural talk.
Sir, is it audible, sir?
Yes.
Audible, sir. Sahil, sir,
Please
slides.
share sir's slide.
Okay. Sharing, sir, sharing, sir.
NIT पटना के कोऑर्डिनेटर हैं प्रोग्राम की
उनकी उसी पे गया मैंने जो जिस ईमेल आईडी से उन्होंने रजिस्टर किया उसी पे गया चला
वही तो किया था। अच्छा
क्या होता है पर्टिकुलर यूनिक आईडी रजिस्टर्ड जो भी ईमेल आईडी रजिस्टर करते हैं उस पर चल जाता है तो हमने किया था उसका टेस्ट
Sir, can we start, sir?
Yes, please start.
Thank you. So the first lecture of this academic program, I decided to give a talk on the introduction to optimization techniques. So basically, I'll tell few fundamentals and any question or doubts on this I'll clarify at the end. Yes. Please, I talk the very, very fundamental. Please try to listen. Optimization technique are fundamentally used to find the best solution in various fields, either by minimizing or maximizing a given objective function. I will tell you what is objective function. So basically, optimization essentially means maximization or minimization. One thing I want to add here, it may be a single variable or that function may be multivariable. I'll give an example. Y equal to sin x, a simple example. Y equal to sin x. So basically, x is a single variable here. If you put the value of x in sin x and get the value of y, it is called evaluation of the objective function. Evaluation, this is fitness evaluation. If y equal to sin x1 plus cos x2, in that case, how many variables? Two variables, x1 and x2. If you want to find maximum value of y or minimum value of y, this is a multi-variable single objective optimization. It can be in a complex problem. Number of variables may be more than 2, maybe 10, maybe 15. In case of finance, manufacturing, healthcare, the number of variables may be large. Second thing, y equal to sin x1, y1, let us call it y1 equal to sin x1, whereas y2 equal to cos x2 plus sin hyperbolic x1. So it is a two variable, but two objectives. Y1, one objective. Y2 is another objective. Simultaneously, you have to perform optimization so that Y1 will be maximum. Simultaneously, Y2 will be minimum. These types of optimization, we call it multi-objective optimization. First one, what I said, is multi-variable optimization. Second one, what I said, is multi-objective optimization. Third one, y equal to sin x, but x lies between 0 to 1, or say minus pi to plus pi. So there is a limit on the variable. If you want to maximize or minimize under this constraint of variable. This is called constraint optimization. What I essentially said, for different types of application in the whole field of education, multivariable, multi-objective, multi-constraint optimization play a very important role. I'll give an example. I have to make a product, and in that product, I want that the cost should be less and the durability should be more. It is a two objective optimization. In our everyday life, in our day-to-day life, personal life, company, and other field, optimization is very, very essential to save time, price, energy, cost, etc. The application of optimization technique, yes, has applications in various fields: engineering and design, structural design, aerodynamics, electronic circuit design, VLSI design are important area of engineering and design, where both single objective, multi-objective, and multi-constraint optimization are required. Machine learning and AI, lot of application. When you are developing a model for forecasting, for classification, there are a lot of parameters known as hyperparameters of the model. And these parameters are to be tuned judiciously to achieve optimum performance. Therefore, optimization play a vital role in machine learning and AI application. In case of finance and economics, optimization are also very, very promising, and it's a lot of benefits. One is portfolio optimization, risk management, stock market prediction. I'll give an example of portfolio management. Please listen carefully. Some people can do PhD, 4 or 5 PhD. For example, you have given 100 rupees and you have to invest in different schemes. Mutual fund, put in the locker, put in some share market. So every investment has a risk factor. How to judiciously divide your total wealth in various scheme of investment such that in a given time, the return will be maximum. This is one of the very, very important area. And thanks to optimization technique, advanced optimization technique, we judiciously solve these types of complex problems. In healthcare and medicine, for example, drug discovery, medical image analysis, patient diagnosis, optimization is very important, plays a crucial. Robotics and control system, path planning, motor control, industrial automation, etc. Supply chain management, route optimization are few examples where optimization techniques, recent optimization technique can be beneficially applied. Application techniques also finds many applications, but very, very important. The optimization technique has many limitations. The classical optimization technique, which is mostly, try to remember, gradient-based optimization. You have to take the differentiation of the cost function, and this differentiation may not be solvable. It may be infinity. You do not get optimal solution. Therefore, gradient descent-based optimization fails. In practice, many researchers, many people have tried to solve that problem, but to the best of my knowledge, for all types of complex solution, particularly for multimodal problem. Remember this word, multimodal problem. Gradient-based optimization fails. Subsequently, operation research and management people use optimization technique with the help of linear programming. But there are many limitations. Nonlinear programming also fails to solve complex optimization problem. I have no time, only I am speaking you to go to the depth of understanding of each of this. Subsequently, heuristic and meta-heuristic optimization technique came into being. What is heuristic optimization? These types of example are greedy algorithm, hill climbing, but this has many limitations. Takes time, unsolvable, and when the problem is complex, you can't solve it. Finally, meta-heuristic algorithm were reported. These algorithms, inspired by nature or biological process, inspired by natural happenings. And these types of meta-heuristic algorithm inspired by nature or evolution are the future and known as the recent optimization technique. I'll speak and give an outline of these types of nature-inspired technique. Let us focus. My talk focuses on nature-inspired optimization technique. This can be split into evolutionary algorithm. For example, genetic algorithm, differential evolution are a series of algorithms which are based on evolutionary strategy. I'll give an example, survival of the fittest. We are monkeys before, slowly from monkey generation we become human being. We don't know what is going to happen after many, many years. So for surviving in the nature, we have to adjust to become robust and survival. Genetic algorithm is an example of this. The behavior of the human being. Genetic algorithm, I'll explain to some extent in this lecture. Genetic algorithm is two types. First one, is binary genetic algorithm. Second one is decimal or real coded genetic algorithm. The first is accurate, takes more time to get the solution. Subsequently, an improvement of genetic algorithm has come, and that is known as differential evolution. It is much faster, it is real coded, and in many situations more accurate. Subsequently, various evolutionary strategies have been reported. So this comes from evolutionary algorithm set. The next category under nature-inspired technique is swarm intelligence. Under swarm intelligence, particle swarm optimization, that the behavior of the birds, PSO, and colony optimization, the behavior of the ants, artificial bee colony, A, B, C, optimization. One thing let me tell, these types of swarm intelligence based optimization algorithm gives appropriate, mostly global solution, but time take. It is a population-based learn. Try to listen that word, population-based learn. Every particle try to solve the problem and associated with them, combine together their own idea and the combined idea solve the problem. For example, the birds want to get the food. They have two characteristics, PSO. First one, they search for food. That's their main objective. But the second one, they protect themselves. To do this and achieve this objective, they have their strategy. They change their velocity, they change their position, and they started at a larger area. But finally, they come to the solution, come to the food source. Same thing happens if there is a danger with them. An improvement on this bird's behavior has come later on. For example, the cat swarm optimization. What I'm trying to say, this is each bird, ants, or honeybee, or fish are tiny, small birds, insects, but collectively they are very strong. So they communicate among themselves to solve and to obtain the optimal solution. Very interesting. There are many types of optimization algorithm based on swarm intelligence are available. I'll give you a list. I was surveying, and the critical analysis shows that about more than 100 swarm intelligence-based algorithms have been reported. It is a, remember, population-based distributed learning system. Very powerful one. Next one is physics-based. Principle of physics, simulated analysis, firefly algorithm, harmony search. These algorithms are based on principle of physics. Little time, just 30 milliseconds. Limitation of classical optimization technique. I told you, gradient dependency. which may not be possible. Trapped in local optima. Scalability for a large scale, difficult to solve. Sensitive to initial conditions. So these are 4 limitations of classical optimization technique. Each one to understand take half an hour, but gradient issue for a multimodal function not possible to obtain the gradient. They fall to local minima, so don't get the global solution. Scalability and sensitive issue. Biological based optimization, on the other hand, improves these issues. Global search capability. Please remember that there can no limitation in the zone. Global search capability. They avoid local optimal position and solution. No need for computation of the gradient, which causes problem. Many of the problem, when you take the gradient, they become infinity divided by 0. So you cannot achieve optimal solution. And another important of the biological based optimization technique, adaptability, adaptation. It can adjust, and it is a self-learning and tuning. Very interesting. These techniques dynamically update, adapt to the changes. And therefore, it is very helpful for real world uncertain environment. Very powerful sentences. Parallelism and diversity. Population-based learning maintains diverse solutions, leading to better results over iterations. As I told in the beginning, optimization essentially can be broken into single objective and multi-objective. In case of single objective, for example, minimization of the fuel consumption in the car while keeping speed constant. So this can be solvable by gradient descent as well as genetic or PSO algorithm. Multi-objective, maybe more than one objective, minimize the fuel consumption while maximizing the speed. 2 objectives has to be fulfilled. Remember one very interesting, powerful observation. This says, if you want to fully minimize the fuel, speed will not be made highest. You have to make a compromise between the two. To make it clear, if your fuel consumption is the lowest, speed cannot be highest, and vice versa. Techniques like Pareto optimal solution and types of multi-objective, non-dominated sorting genetic algorithm or multi-objective PSO are, for example, which try to fulfill the satisfactory solution for multi-objective optimization. If you look to this diagram, it gives a clear picture. The nature-inspired algorithm has 4 branches: swarm-based, human behavior-based, the third one is evolution based, and the fourth one is physics based. So basically, the nature-inspired technique can be split into 4 types. And for each type, I have given the name of some of these algorithms. Each algorithm is very, very interesting. And these algorithms are population level. Single solution cannot start. You have to start with a set of initial different solutions. And finally, all solution will converge to one global solution. I will teach 1 or 2 such algorithms in my class tomorrow. The evolutionary algorithm, I am given some example. Genetic algorithm. Genetic algorithm has few stages. First one, initialization. Second one, selection. Third one, crossover. Fourth one, mutation. And then the population will increase. At the end, if I find some time, then I will explain you little details about genetic algorithm. The evolutionary strategies leads to very, very interesting algorithm. Start with the real numbers, followed by mutation and crossover, and that lead to appropriate optimal solution. In addition, evolutionary algorithm can also be considered genetic programming, evolutionary programming, and differential evolution. I'll give an example of differential evolution. A differential evolution, here mutation comes first, then crossover. Whereas in genetic algorithm, crossover comes first, then mutation. And differential evolution is an improvement both in speed and accuracy compared to genetic algorithm. So evolutionary algorithm, highly adaptable, widely used in engineering application, finance, and healthcare. Next. So I'll give an example of genetic and evolutionary computing at the end of my lecture. Just see, coming to genetic algorithm, I'll explain for 5 minutes. It is survival of the fittest. Let us say y equal to sin x. Find the value of x at which y is maximum. Now, initially, you have to first decide the population size. Let us take population size is 50. That means 50 initial solution. Solution can be positive or negative. Value of x. Therefore, generate a random number, subtract 0.5. That gets the first solution. Repeat it 50 times. That is the initialization. Now, out of this 50 initial solution which are not correct, then what you have to do? You have to assume that 20% of this population will cross over to produce children. And 20% of 50 is said 10. So out of 50, 10 will not produce any children. So 50 minus 10 is 40. 40 can be paired into 20 couples, and each couple will cross over. There are many types of crossover. Single point, multi-point, 2 point. If the variables are more, you have to go for multi-point crossover. If your number of variables is single, you can go for single point crossover. If each solution, which is called gene, and a set of genes, for example, 10 genes constitute one solution, which is called chromosome. So there are 50 chromosomes, out of which 40 chromosomes will cross over. And you select them based on their fitness. So if the first and second will cross over, then produce a pair of children. So if 20 such pairs will cross over, they'll produce 20 pairs of children. And 10 pairs which are left over will not cross over, like bachelors. So in general, after crossover, the total population size will be 40 parents, 40 children, and 10 bachelors. So that comes to 90. Now this 90 population increased from 50 to 90, comprises of parents, children, and bachelors. Now you have to perform mutation. In case of mutation, you have to choose randomly a bit inside the chromosome, randomly. And if it is a 0, make it 1. If it is a 1, make it 0. But you remember, very important, 20% of the population will not make. That is crossover probability 0.8. Whereas in mutation, the mutation probability is very less, of the order of 0.2. So out of 90 into 0.2 is 18. So 18 out of 19 randomly selected, and from those randomly selected solution, a particular point in the bit position is identified randomly. That is generated random number, multiply with the number of bits, take the integer part. So go, suppose it is 4, go to the 4th bit, and if it is a 1, make it 0, and vice versa. Repeat it 18 number of times. After that, evaluate the fitness value. Is chromosome converted from binary to decimal? Put the decimal into the fitness function, y equal to sin x. Put the value of x there, evaluate y1 up to y2, and so on up to y90. If it is a maximization, order them from highest to lowest. If it is a minimization, order them from lowest to highest. And keep the first 50, because it is a constant population size optimization. And discard the less fitted population. That is, last 40 you discard. This process of selection, crossover, mutation, and fitness evaluation, 4 processes constitute one generation. Repeat the generation. It will be established. You started with the 50 initial solution. After some generation, all solution becomes same. And take one of the solution, put into the function, you get the highest value or the lowest value. Very interesting. But it consumes time. One thing I'm telling to all the participants, please listen. Today, to reduce the time of computation, because it is a population-based learning, distributed, biologically inspired, or evolution computing based algorithm has one that reduces time, gives accuracy, get optimal solution. So genetic algorithm, this I explained to you just now, all the points I explained. Next one. So this I have already explained to you. Genetic algorithm is used for machine learning, engineering application, scheduling and planning problem, financial forecasting and portfolio management. Lot of potential application. Still now, even though hundreds of bio-inspired technique or nature-inspired technique have been published, still GA finds a potential application in many fields because of its simplicity, robustness, and performance. And I told you the improvement over genetic algorithm is differential evolution. Yes. And this algorithm is a real coded, it is not binary. I told you, remember very powerful word, binary based GA algorithm takes more time but accurate. Differential evolution provides similar solution but much faster, at least 5 to 6 times faster. And here it is similar procedure as GA, but fast mutation takes place and then crossover. Otherwise, it is similar. Next. So I'm not going to all this detail. I'm giving the overall overview. So I've made a comparison between GA, D, and ES. Essentially, what it says that D is superior to GA in many aspects. Next one. Next. I have made a exhaustive review of existing bio-inspired based technique. Here what I have written, name of the algorithm, the year, the author name, who started, and next one, the title of the paper in which GA has been first reported. And if you look to this continues, types of GA, many variation, then types of different algorithm. Next. Yes. Genetic program. A lot of variation, differential evolution. And many variation of the swarm intelligence based and colony optimization, honeybee algorithm, fish algorithm, bacterial algorithm, beehive, bee swarm, many variation of honeybee algorithm. You can also, if you understand 2-3 algorithm properly, you can start your own algorithm. I made a review and I found there is a long list which are this was published and applied to which field. So there are about 110 bio-inspired based optimization techniques. Now, I'll tell something which I have already told on particle swarm optimization. It was reported by Ibarha and Kennedy long back, 1992, about 32 years back. The details have been given here. As I told, basically, particle swarm optimization follows two things. Initially, they have a position. So 50 birds at 50 different positions searching for food. The position, each bird also has their velocity. They move. They are moving randomly. But by virtue of searching food and between cooperation, which is called G-best, and their own position P-best, with the velocity, they update their P-best. And the best of the P-best is called the G-best. And finally, all birds which are moving randomly across miles come to the food source, and that is the G-best. Everybody personal best become their position and become their G-best, which is the global solution. Very interesting. Ant colony, whether you know or not, I'll be teaching in details about ant colony optimization tomorrow. It was started in 1992 by Dorigo et al. And I'll give an example. Suppose you are sitting in a room and listening my lecture. I put a sweet, some sugar at some place of the room. You observe, after 10 minutes, any ants present in that room come to the sugar and they pick the sugar, don't eat, take the sugar to the nest. Initially, they randomly move, but finally, they follow a path from food source to the nest. And that is the shortest path, and that path they can able to find because, remember carefully, each ant throws a liquid, spray liquid known as pheromone, and all birds smell, all ants smell that pheromone liquid and follow that path. That is how they move in a single path. If you look to the next diagram, you'll see first figure, single ant is there, single ant. Subsequently, from the food source to the nest, they are moving in different paths. But once, because of their pheromone intensity, which they can able to smell, where there is more pheromone intensity, the next ant moves that path. And you'll see in the third figure, they are following a single path, and that is the shortest traveling salesman problem. And similarly, many transportation problem, networking problem in 6G can be solved by ant colony optimization. Tomorrow, I teach for 1 hour, at least ant colony and maybe Billy cat swarm optimization algorithm. Very clearly, very simple way. With example, try to attend my lecture tomorrow. I told about differential evolution 1995. This I have already told, much faster than GA. Artificial immune system. It was reported in 2002 by Castro and Joubert. Remember one thing, our human body becomes immune to some disease, to some environment. Initially, we may fall to chickenpox or smallpox, but once you are suffering from smallpox and you got cured, your body become immune. Next time, falling to chickenpox or smallpox will be less probable. That is, body develops an immune system. So how the immune system is developed based on that principle, artificial immune system have been reported, very powerful technique, and reported in 2002. So this I'll make it little highlight next year. So basically, I'll explain what is antigen and antibody. Basically, the body has a particular antibody. So when the virus comes, they try to match to their shape and catch them. Do not allow to expand. That is how you do not fall to any disease. Once you fall to that disease, before that, body develops immunity. Very interesting. We have done a lot of work in this area. Another interesting bacterial foraging optimization have been reported in 2002. Every bacterial search for food and they follow chemotaxis, swarming, reproduction, elimination, and dispersal. They are the four principles they follow, and bacterial foraging optimization, they basically try to get their food. Very interesting, very powerful algorithm. And your cat swarm. Tomorrow I'll teach for 15 minutes. Every building have two principles. Seeking mode, tracing mode. If you are sitting in a room, if there is a cat, the cat will be sleeping somewhere under chair, under cot, or some corner. But they are not tall, they are not sleeping, they are very active. They mark every movement of the room. Suddenly, suppose a mouse runs from one corner to another corner. This cat, which was in a seeking mood, tracks. Suddenly it moves at a high velocity, catch the cat. Therefore, this seeking and tracing behavior is very, very interesting. One thing, in case of PSO, birds' behavior, they have only tracing mode, they do not have seeking mode. So seeking and tracing mode are combined, improves the optimization performance of CSO compared to PSO. This was reported in 2007. Remind me tomorrow after end colony optimization, I'll teach you cat swarm optimization. Similarly, fish swarm optimization, behavior of the fish. Suppose some food is there, how they are moving in different place in the pond or river, how they come to the food source is very, very interesting. And based on that, fish swarm optimization technique has come into existence. Next. Similarly, harmony search, very interesting. Musician phenomena of mimicking algorithm inspired by the improvisation process of musician gives rise to harmony search algorithm. No time on my part to explain, but remember, HSA is a very powerful algorithm optimization, multi-objective and single objective optimization. Next. So there are many multi-objective, as I told, both single objective as well as multi-objective. That is, I'll make a product, price will be less, durability will be more. So multi-objective optimization has become very, very important. I have given a list of multi-objective optimization. For each of the bioinspect technique can be converted to multi-objective for solve complex problems. But till today, not much multi-objective optimization techniques have been reported in literature. If you are interested, and if you understand few of the multi-objective, you can do research and publish more multi-objective, powerful bioinspect technique based optimization. This I have made a list of different multi-objective optimization and their common application. So basically, time as well, I'll give a list of our publication. Last. We have applied to that. We have applied this optimization to wireless sensor network for saving power, for elongating the life of the sensor. Next, this is just an application. Multi-objective. These are publication of Professor Panna's group in the area of evolution. We have all SCI paper and high quality paper only on optimization applied to finance, applied to cognitive radio, applied to stock market, applied to sensor network, finance, etc. So if you slide, then you can see many of it. This I can share to our Dr. Nanda, the coordinator, who can give you to see more details on this. You can find and enhance your knowledge and strengthen your research in this field. So this is, since 1 hour is not sufficient, I only touched it. So thank you for the opportunity. I shall appreciate if one or two questions are asked and I'll be able to clarify. Please write or speak out so that I can give the answer. Maybe 1 or 2.
Thank you, sir, for this very informative session. We are simultaneously trying our best to answer the queries of the participants in the chat. In the meanwhile, whatever they are asking, myself and Dr. Illa, we are trying the thing over chat. So
yes, basically,
if there will be more questions, we will be passing on the same to you so that tomorrow session you can able to answer those questions, sir.
The question is very interesting. There are more than 100 bioinspired based optimization. Now, when there is a problem, there is no rule which optimization will perform the best. Your experience, your expertise, This is a trial and error. Till today, no empirical formula, no guidelines are there. This is a virtue of the experience of taking the experts and senior. Number one. Number two, that basically some of the algorithm takes less time getting the similar accuracy. This, if you review it, you can be able to identify. But I strongly feel that the parameters in the hyperparameter of the algorithm is to be tuned judiciously. For example, now population size, the crossover probability, the mutation probability, number of iterations, and types of crossover has to be chosen. And there's no mathematics is there. Therefore, these bioinspect techniques suffer from one of the problems. There is no rule and guidelines to choose to get the best solution. This is my experience. But if you take the advice of the experts, they will guide you, help you, but no formula, equation, or guidelines are there. Thank you. Second question. What is red deer? Tomorrow I can tell you red deer for 5 minutes. It is also the behavior of red deer. You know, deer, red deer, their behavior has been coded to develop an algorithm which solves single objective optimization problem. Another question, can you solve multi-objective problem using GES? Tomorrow I'll give 5 minutes NSGA2. The IT Kanpur Mechanical Engineering Kalyan Moete, they are BTech students who are in the US, have developed in their GA algorithm lab NSGA version 2, non-dominated sorting genetic algorithm version 2. So this is given by the mechanical engineering student, BTech student of IT Kanpur. Next question, how to use PSO for ODE constant problem? What is ODE? I could not follow. ODE. How to use PSO for ODE constant problem?
I hope they're asking for ordinary differential equation solution. ODE.
Ordinary differential problem.
Evaluation.
Yeah, it is. You have to convert to difference equation from differential and solve it by using TH. That is possible. See, differential equation has two parts, transient solution and steady state solution. You can be able to convert your problem into a corresponding difference equation, and then you can use PSO to solve the steady state solution, not transient solution. Solve multi-objective using the possible. Yes, possible.
Sir, we can
Single D, I forgot one thing. Single differential evaluation can solve single objective, but a multi-objective problem can be viewed as a single objective and can use it. Otherwise, a multi-objective can also be used to get a better solution. Thank you.
Sir, the questions we can take up later. I am very much thankful, sir. You have provided a brief introduction to all meta-heuristic algorithms as a introductory part, and you have also given idea about the classical algorithms also. So with this, we will be concluding the first talk of Professor Ganapati Panda sir. And our next speaker, Professor BK Panigrahi sir is already there. So, thank you, sir.
Thank you.
BK Panigrahi sir, we will be starting your session.
Yeah.
Please give us just 2-3 minutes time so that
Yes,
we
yes.
can just start the YouTube link for the same. So give us just 2 minutes time, sir.
Sure, sure, absolutely, no problem, no problem. Please, let me share.
Sir, please share your thing.
Is it